Chapter 7 and Chapter 8. Chapter 7 is just going to deal with an alternative way to write R code from how we've been doing it in the past on the command line. It's called RStudio. It's kind of cool. And Chapter 8 is going to add some functions into our toolbox of R and how we can make a programmer defined function. So let's get started. For Chapter 7, we're going to explore R beyond the R console, and that's what we've been using prior to this, okay? There's a free environment called RStudio. It's going to allow you to do all of your R coding in one place. It also does Python. It allows you to easily save your items, so we're going to kind of dive into that today. We're going to download and install that RStudio environment, get familiar with the layout, the tools. Then we're going to write a few different scripts and learn how to save them. RStudio is considered an integrated development environment, or an IDE. This is a generic programming term. Okay, it's used for many different programming languages. It's not specific to R. So if you hear anyone ever talking about an IDE, they're talking about an integrated development environment. An IDE is going to give the programmer an environment to go beyond typing those commands line by line. If we had to do every single, data mugging line by line, it would take forever to get anything done. So an IDE is going to allow for saving of those commands to eliminate retyping, allows reusability. It's also going to eliminate some errors. Once you get the code working the way you want it to, you can save it and then just reuse it. So the IDE is going to store all of this code into bits and pieces, and it's going to execute them that way. Again, you're going to have save time with limiting errors and the reusability. And RStudio is, it says but it is one of the IDEs for R, and again, it also does work Python. So let's get started to the installation. So first, before I switch over to my screen view, we're going to go find the latest version of R and how to install it. We're going to go to www.rstudio.org. Okay, we're going to download and install a desktop application. So then we're going to create a new R script, and we'll kind of point out a bunch of the different tools and the different areas of the RStudio. So let's get started and take a look. We're going to open up our internet browser, and what we're going to do is we're going to say www.rstudio.org. Okay, so it's going to take us to the RStudio website. As you can see here, they've got a whole lot of different products that are available. So what we want to do is we want to go up to products. We want to go to the RStudio. That's what we want to install. So take control of your R code. We're going to scroll down. We're going to say RStudio Desktop. Okay, open source edition, that's going to be your free edition. So go ahead and download RStudio Desktop. Okay, choose your version. Again, we just want the free. We want the desktop, not the server. And then finally, we're going, and this does require the R to be installed, which we've already done. So we're going to go ahead and install RStudio. Okay, once it's finished downloading, let's go ahead and click on it to go ahead and install. We want to allow it to make changes. Yes, and then we're going to get the installation. So I'm just going to click next. It can go ahead and create shortcuts. Doesn't matter to me. So I'm going to let this install, and I'll be right back. I've gone ahead and I've started RStudio, and what you can see some things that look familiar and some things not so familiar. On the left-hand side over here is exactly what we had when we were running the console out of R. Okay, over here there's some variables that are going to pop up there, which we'll see in a minute, and you've got a file structure down here. Now, what we want to do, though, the whole point of using the IDE is up here we can say a new file. So we can create projects, we can create notebooks. We can create all kinds that you can see here. Here's your Python. But let's go ahead and click on R script. Okay, so what that's going to do is that is going to create a new script file. So what we're going to do is let's type a few things into this just as we would onto the console. So let's say tiny data. Let's give the assignment statement and let's make a list. So C 1, 2, 1, 2, 3, 3, 3, 4, 5, 4, 5. Okay. Okay. On the next line, let's do min tiny data. Let's do a mean of tiny data. And let's do a sum of tiny data. Okay, you can already see some differences. So one of them, as you type the command, the tooltip will come up. So let me do that a little slowly. There. And what it's going to give you is it's going to give you some information going forward on that command. Things such as what arguments is it, what kind of return does it have. Then as you type it in here, it is actually going to pop up a suggestion as to which variable that you need to put in there. You can actually go ahead and click on that and it'll automatically put it in. Okay, I'm going to delete that line because it was a duplicate of the line above it. So this up here is considered the source code pane. It's going to be your source file. Okay, so when we run it, what we want to do is source on save. Okay, we can go up here and hit the save button. What it's going to do is it's going to ask us what we want. So let's just call it script1 and save. Okay, as we can see over here on the right hand side, it's actually created our variable and it has in it what the variable is currently containing. That can be extremely, extremely helpful. Okay, so you'll notice another thing that this code is not going to have that command prompt like we have down here, like we had in the console, the greater than button. Okay, that's because we are actually writing in the source file and not in the console. This code again can be saved like we just saved it, and when it runs you're going to see the output in this lower left. So I'm going to make this a little bit bigger so I can see. Now big difference here is that in order to run it, we click over here next to source and we want to say source with echo. Okay, when we do source with echo, what it's going to do is it's going to echo each command line by line down in the console window. So now your RStudio should look very similar to what is here. Okay, the other nice thing is that in this top you can put blank lines. It's not going to matter, it just ignores them. And again, you can save. You know that it's been saved. If this is black, if it turns red with an asterisk, it means that your changes have not yet been saved, such as that right there. You can change this output by writing more code into the source file. Let's add a vector of 5 more than tiny data. And then we're going to put it into a data frame. And let's change the column names to reflect big and small. So let's go ahead and do that. So let's go up here. First, let's bigger data. Do the assignment, tiny data plus 5. Remember, we wanted to add 5 elements. Let's create a data frame, df. Okay, we're going to do the assignment, data.frame. We're going to send it tiny data and bigger data. Then what we want to do is we want to change those column names. So call names, data frame, assign it, whoops, small and big. There we go. So another way to execute this data is you can highlight it. So let's click on the highlight and then you can click the run button. If you do that, it's just going to run the ones that you've highlighted. Now, some of the things you can see here, again, we've got some things going on that make the IDE a lot more friendly than the command line. Over here on the right, we've got this environment. Okay, and in this environment, we've got a list of all of our variables, and you can actually see what's in them. So that's actually really nice to know. Okay. You can do, there's a history. Here is a listing of all your previously executed R commands. There's also tutorial. So this you can actually, let's see, here's the arrow, there we go. There is our data frame. You can see the different aspects of the data frame. You can see your small and your big, and there are the values for them. So that is helpful with the contents when you're looking at a data frame. Now these values down here are just lists, so it just lists the number. That's all there is to this RStudio. So you can see how this is going to be a lot more in depth, and it's going to give you a lot more information going forward rather than trying to display your data frames and your lists every single time you need to use them. So that's all there really is for chapter 7, which is why I lumped it in with chapter 8. So now let's talk about functions. So from here on out, you can use either the RStudio or the R command line. It doesn't matter to me. Okay. I do like the RStudio because I like the savability. I like the different tools. I'm used to working in IDEs from other programming languages. But again, that's my personal preference. I would like you to go ahead and find your personal preference. Either one doesn't matter to me, okay? So just going forward, no, either environment is fine. So chapter 8, we're going to talk a bit more today about functions. We talked briefly about them last week when we talked about sum and mean. But what we're going to look at today is creating your own functions or programmer-defined functions. So first, we're going to look at the benefits of using functions in R. We're going to learn how to write some functions in R. Then we're going to explore some pre-coded functions that are out there available to you that might be helpful going forward. Remember, we don't want to reinvent the wheel. If there's something out there and it is usable, we want to go ahead and use it. So, first things first, why do we need functions? Functions have two main benefits. It's going to add reusability to your code, and the second is a term called abstraction. So, abstraction means that we don't need to know what's in the middle of the function. We just need to know what to send it and what we're getting back, okay? When we use those functions like sum and mean, we didn't know exactly how it did what it did. All we knew is that we had to send it a list or a data frame, and we knew that what we would get back. Okay, that's abstraction. So it's just basically hiding what the details of what's going on from the user. Okay, the arguments is that extra information that we're sending to the function. So those values that we sent to the function. So for sum, we sent a list. Okay, that list is the argument. What was returned was all of the list items added together. Okay, so you'll hear the terms like arguments, and that means what we're passing to the function. So let's go back into R. We're going to create our first function. But first, I want to talk a little bit about functions. What we're going to do is we're going to create our very first function. So we're going to type in my mode. And my mode is going to be the function name. And there's going to be an assignment statement. Remember that less than dash, okay? So the R assignment statement. Then there's going to be the word function. Then in parentheses, you're going to have your arguments. In this example that we're going to do first, your argument is my vector. Okay, some things to point out. The function is capitalized at the beginning and the variable is lowercase. It's kind of a quick and easy way to determine whether you're looking at a function or a variable because they're all going to kind of look the same. So after that assignment statement, you're going to have a set of curly brackets. So there's going to be an open and a close, and anything within those curly brackets is going to be what your function is, okay? It's going to be called a block of code. In this function, we're just going to put a simple return statement. That return is a keyword. It's going to say send this back to whoever called the function, okay? So in this form right here, what's in the white box, very simply, it's going to take a vector and just return it back. It's not actually going to do anything, okay? It's going to be just a super basic function. We're going to add more to it when we get into the R. So let's go open up RStudio again. Let's go back into our source code and let's create that super simple function. So we're going to type in my mode, and to do that, we do that assignment operator. We say that it's a function, and we're going to send it well, if I can spell, my vector. After that, you're going to put the curly brackets. You can see the IDE, if you're going to do on the source code, is actually going to put your closing pair and is going to indent for you. So that's always a good thing to have. Now, all we're going to do is return. Again, if you type the command, it will come up and it will explain to you a little bit about what it does. So this is function definition. The functions are going to return a value. It's going to return a base. So let's say return parenthesis, and we're just going to say my vector. Remember, because all we're doing in this very first function is we're just going to spit out what is given to it. Okay. So let's run this for my vector. Over here, it actually adds function, my mode. It's a function and you send it a vector. It actually has a lot of explanation in there. You can see down here in the console, it has those plus signs. We talked about those plus signs probably lecture 1 or 2 about how it's just a continuation of what is going on. Okay, so let's go down here into the console window because you can actually go between the two. And let's type in my mode and let's send it tiny data. Okay, let's see what happens. Okay, because we ran this my mode, it's going to go ahead and it's going to give you those numbers. Okay, if we had not run our script up here and had these lines not executed, it would give you an error. So let's do something where we spell it wrong. Okay, there's your error. So if you have to have that function run in the R prior to using it. Okay, so it's when you run the function, it's actually going to have it up in its memory, see over here on the right, and then you can actually use it. So let's go in and let's add some new commands into our function up here. Let's add, let's see what we can add. Let's do unique values. So let's go up here and add before the return. The return, it kicks it out of that function. So before, let's say unique values, let's store in it unique vector, my vector. And then what we're going to return, let's return those unique values. Okay. Now, so unique is a new function that we've not used before. It is one of the ones that's built into R. And it's going to identify any unique values in the vector. It's going to count how many times they occur. And then it's going to return the one with the most occurrences. Okay, so we can come over here. We can select the code and hit run. So now we've updated our my mode function. Okay. Now, let's try down here. And now, an easy way that we can reuse code is if you hit the up arrow, it'll actually retype it'll go through the commands in the history. So if I hit it twice, well, 3 times because I did the error one. So if I go back and I do the my mode capital with tiny data, it's actually going to return something different this time because we've added those unique values. So what it's going to give you is the 1, 2, 3, 4, 5. Okay, so it's going to take that big list that we had up here on line 1 and condense it down to just the unique values. Okay, so now let's add a little bit more functionality into this. So after that, let's just say unique counts. Unique counts assignment, and let's use tabulate. Now, if we go back to my tabulate, okay, what my tabulate is going to do, if I can get it to work, my vector, there we go, return unique counts. Okay. Now, what tabulate is going to do is it's going to count how many times each of those unique values exists. So let's highlight just the function again. We don't need all that other stuff because nothing's changed. Let's run that function. Okay, we can see down here it's done. And then let's see what happens when we say my mode, tiny data. Okay. Now, here we can see we've got a difference. Now, what it's giving back to us is it's giving us back the number of occurrences of each of those values. So let's take a quick look at this in a table. Quick interjection. Let's check the table and make sure it's returning the correct figures. So we're going to read the table by reading the bottom row for the largest number, the most frequently occurring values, and then check the corresponding index for the unique values to see which value it was. So you'll see how they start to match up. So you've got 1, 2, 3, 4, 5, and the counts of each number are below it. We're going to add one more built-in function to our cute little function here. We're going to use something called which.max. Now, which.max is going to find the index of the element of whatever you send it that is the largest. So let's do unique values. Okay, what we want is we want to display the unique value that has the largest count. Okay, so unique values, square brackets. Okay, so we're going to go into that list of unique values. Now, the indice that we want is we want to know which one is the max from the unique counts. So, which one is the max of unique counts? Okay, you see how we're building this up, okay? So, unique values is the list from up here, okay? Unique counts is the count of each of them. You go into the values and you want the value where it's the max of the counts, okay? And then what are we gonna do? Okay, so what we actually want to do is we want to return that value. So let's go ahead and do that. Let's get rid of that. So you can do this in 2 steps. You can do it in 1. Really doesn't matter. You can assign this unique values which max to a variable and then return the variable, or you can just return it right from there. So let's go ahead and highlight that and run just that function again, because again, everything else is the same. And then come down to your console and let's run the my mode tiny data. Now what it should give us, right? So here's my mode, 22322. I want to know where the 3 is, right? Because your 3 is the max. That's where I want to know. So that should give you the number 3. Okay, so let's hit enter. Okay, so it goes in, finds the max of the counts, and it pulls out what number that's associated to. So your final function should look something like this one. So what it's going to do is it's going to see how many unique values are in a given vector that's going to be sent. So it's going to count up all of those numbers. But let's look at the next step. After you code, is the ever important step of testing your function, okay? The point of testing is to break it. So what we're going to do is we're going to add some figures to the tiny data that called the my mode in an attempt to break it, okay? We want to see where my mode is going to fail. We're going to do 3 different things. We're going to add 3 more 5s, we're going to add some extra 1s, and then we're going to add some extra 9s. And let's see where we can break this function. Let's take a look. Now I did something a little unique here. If you come up here into your console and there's a little broom looking thing, if you click that, it'll clear console out. Okay, so just a little hint. So let's add 5s. Let's add some 5s into the tiny data. So tiny data, the assignment operator, we're going to concatenate the tiny data that's already there, and then we're going to put 3 5s. Okay. So now if we display tiny data, okay, we've got those 3 additional 5s at the end. Okay, there was already a 5, we added 3 more. So let's go into the My mode and set it again as tiny data. Okay, now the 5s have the most frequency because there should be 3, there should be 5 5s. Okay, so that works. Okay, so it's going to return the number 5 because we're maxing out at 5. So now let's add some 1s and let's see what happens. So I'm actually going to be lazy and I'm going to go up here and I'm going to add 1, 2, 3 ones. Now, what's going to happen? So for the number 1, we're going to have 5, and for the number 5, we're going to have 5. So let's see what's going to happen when we do it this way. Okay, it's going to return the first mode that it found. So in the original tiny data up here, 1 comes first. Therefore, even though 1 and 5 have the same number, it's going to pick the one it finds first. So it's going to return that 1. Okay, so these are the things that you're going to find out during this testing mode. So now let's add some 9s and let's see what happens. So let's add 1, 2, 3, 4, 5, 6. Let's add 7. Why not, right? Okay, now let's run our My mode function again. Now, originally, remember, we only had 1, 2, 3, 4, 5. Now we have 9. So what's going to happen? Okay, we get an NA. NA is basically R's way of saying that there's an error. Okay. After we added a lot of those 9s to the end of tiny data, it added 0s to cover the 6, 7, and 8, okay, that it was expecting. Okay, this is going to produce more unique values than what the unique tiny data counted. So you're basically going beyond the number of the list. Okay, we can actually fix that. What we can do is we can fix that by using a built-in command called match. So let's go back up into our function up here. Now in tabulate, because it's the unique counts that's throwing it off, okay? We're going to come in here, we're going to type in match, okay? We're going to send match my vector and unique values, okay? So what this match is going to do is it's going to match up all of those discrepancies. Okay, so you're going to tabulate every single possible value, including the ones that there's no data. Okay, that's what the difference is going to be. So let's go ahead. You can see here the X's that I've added some stuff. Let's go here, highlight and run. Let's go up here and go ahead and click run. We're going to highlight and we're going to run. Yes, I screwed up the first time. It's fine. Okay, there's our new function has now been run, and let's go ahead and in here, let's run the My mode in tiny data. Okay, now remember, we added that match, so it's going to match up everything. There we go. Now it has the 9. Now we know our function is accurately running. Okay, awesome. So now we know where its limits are. Let's go ahead and add the match function. Okay, what that's going to do is it's going to help match up those unique values when it is tabulated. Few things to remember, don't forget to save. R is full of functions and we just tapped into a few more like unique, tabulate, match, which max. You can search online and you can find basically an infinite amount of functions. Most of them are free to use and to test. Looking at some other people's code sometimes is a great way to learn how to do certain things. The statistical information does have a specific, what they call package, which is a group of code. That's going to be where most of these functions are going to be found. It's called ModeEst, okay? It's going to actually stand for Mode Estimator. Okay, so let's go ahead and install it into our RStudio. Let's go ahead and install that ModeEst package. So down here on the right, under Files, there's Plots, and the third one in is Packages. So you can look here, and everything in here is what's available to you from your automatic download and install. The check marks are the ones that are already in use. So if we come up here to the search and we search for ModeEst, okay? It's not there, okay? Which means it's not already in there, which means we need to install it. Okay, so we're going to click on the button that says Install Packages right here. Okay, that's going to give us a dialog box. Over here, we type in the package. See, it comes right up, Modest. There we go. Okay, leave everything else the same. And what we're going to do is we're going to click on the Install button. Okay, there's going to be some instructions and some code and some things going on over there in our console window. Okay, what it's doing is it's going and getting the package and it is downloading it and it's installing it. Okay, now once it's complete, what you should be able to do is here is if you type in the Modest, there we go, the mode estimation. That's the one that we just installed. So what we want to do is the last step is to go ahead and check that checkbox in there and tell the IDE and tell R that we want to use this library. Okay, so now within that, I'm going to go ahead and clear this so that you guys can see it. It's a little bit more in the center of the window. We're going to try a function. It's called MFV. And so what this is going to do, it's going to return the most frequent value. Okay, you can send it a vector, and typically it's what we want when we want in a mode function. So most frequent value, MFV. Okay, again, because we installed that library in that package, it will come up when you choose it. So let's send it tiny data and let's see what we get. Okay, so far so good. This is exactly what our my mode function up here did. Okay, typically it probably can use a different method, but you know what? We can actually look. So down here, let's actually type the function mfv and nothing. This is just how we viewed what was in a list or what was in a data frame. We just type the name and we hit enter. Okay, when you do that, make sure you remove the parentheses that it wants to put. It's going to tell you that it's a function. Okay, here's going to be the use method MFV. It's going to give you some information. It's going to give you some environment information. So one of the nice things about the open source is that you can see what's behind it, okay? So also here on the packages, you can click on the package name and it'll take you to that help view. You can search these functions. And here we go, mode estimation. Okay, it's going to give you a description. You can go back and forth. So what that's going to do is it's just going to explain to you what the function. So that's all there is to working in the IDE and how to create functions, both your own and how to import ones that are out there. Again, don't forget assignment 3 and the final project proposal of how you're going to do it, what you're going to do, and things like that. So can't wait to read, you guys. I'm kind of excited. So see you next week. Happy coding.